Hi. Hello, everyone. Thank you all for joining me today again. I'm Judy Piper. I'm one of the engineering leads at C Labs and also the host for this Celo Tech Talk series. Celo is a mobile-first full-stack blockchain platform with a mission to build a financial system that creates the conditions of prosperity for everyone. We recognize this is an ambitious mission, and we're building Celo with our community and end users all around. And for this reason, we started the Celo Tech Talk series to share and spread the Celo technology knowledge with the growing Celo community. And last week, York Rose, protocol CAP engineer at C Labs, gave a talk on Celo's contract release process. This week, Alex Harley, who is also another protocol CAP engineer, joined us today to talk about CIP-8. And we'll have a quick Q&A session at the end of this session, but you can use the Ask a Question menu on your screen, at the bottom of your screen, to add your questions anytime. And there's a poll. If you can take a poll, that would be great. And a friendly reminder, though, to keep your questions relevant to today's Celo Tech Talk topic. Welcome, Alex. How you doing?
Hey everyone, good, thank you.
Yeah. But before we get started, let's get to know you first. Yeah. Can you introduce yourself and how you got to work on Celo?
Yeah, thank you. So hi everyone, my name's Alex. I've been here at C Labs working on Celo for the past 10 or 11 months. Throughout that time, I've primarily been at the intersection of two teams, the contracts and primitives team and the developer experience team. They're pretty closely tied together, so I find it a nice fit. I'm based out of Berlin, Germany, but I'm from New Zealand originally. And before joining C Labs, I was involved with another Berlin blockchain company. We were running a proof of authority based Cosmos blockchain. And yeah, at the end of it, I just felt like my time there was over and I was happy to join C Labs working on Celo for the greater good, really.
Awesome. Alex, we have a poll result. Let's get to it. So you have two truths and one lie, and which one is a lie?
Do we want to wait for people to vote? Oh yeah, okay. Yeah, no. So I'm not related to the Prime Minister of New Zealand. Only one person got that right, so well, congrats.
This disappoints me greatly. You were supposed to introduce me to your Prime Minister.
I know, that could have been your claim to fame.
That's right. And it looks like most folks came from Celo community, looking at the Celo community calendar. But if you can say hello and share, feel free to share where you're joining us from. I'm based out in Berlin, Alex as well. Yes, it is quite late outside, and that's how committed we are. So thank you for coming. And pay attention, don't fall asleep. All right. Okay. Are you ready?
Mm-hmm.
All right, let's get started.
Awesome, thank you. So yeah, thanks everyone for joining my tech talk on CIP-8. In a nutshell, CIP-8 is a standard for accessing off-chain data. However, I see it as more than that. I see it as an ambitious and far-reaching proposal that will affect many areas of the network. Everything from helping us achieve Visa-level throughput to displaying profile pictures in your Valora transaction feed. So there's quite a bit to cover today. The first point I want to bring up is just why should we be storing data off-chain? It's a really good question. After all, that's kind of what blockchains are for. So why wouldn't we use it for that? Afterwards, we'll be doing a deep dive into CIP-8, touching on what prompted us to make this proposal, why we took the route we took, what came before CIP-8, and the privacy implications of storing data off-chain. So before we get into that, I just want to step back for a minute and reiterate our mission at C Labs. So at C-Labs and with Celo, our goal is to build a financial system that creates the conditions of prosperity for everyone. This mission informs everything we do, and it's important that we always phrase work in the context of this. If it's not going to help this mission, we probably shouldn't be engaging with it. So the first question we need to answer is, why should we be storing data off-chain? It's a little bit hand-wavy to say storing data off-chain helps create financial prosperity for all. So let's list out the context. Let's list out the benefits in the context of this. The first reason for off-chain data storage is that blockchain storage is very expensive. As a parallel, we can look to Ethereum and see that at the time of writing, storing a single gigabyte of data on Ethereum costs upwards of $76,000. This creates a huge barrier to entry for almost everyone in the world. However, for Celo's target market, who don't have access to a lot of funds, this becomes even more relevant. Because it's so expensive, we have to make trade-offs with what we decide to put on chain. As an example, in our core token contracts, the Celo native asset, the Celo dollar, and the Celo euro, we have a transfer with comment method you may be familiar with. This is for attaching a small piece of human-readable data to a transaction. If I were to send you $5 for lunch, it might be nice to say, hey, this is for lunch money. This is lunch money. But with these potentially exorbitant costs, we need to make these comments as small as possible, resulting in friction for developers building on Celo, as well as a degraded end-user experience. The second reason for off-chain data is that not everything requires the cost of hard consensus. A lot of network metadata only needs to be verified by the individuals involved. The example I'll give here and keep coming back to throughout this talk are profile pictures and names. If I want to register my name on chain, that doesn't necessarily need to go through the whole consensus engine. Only people who want to transact with me are likely interested in that. As an addendum to this point, the less data we have flowing through the system per transaction means that more transactions overall will be handled. This is going to be key in achieving the Visa level scale where we can handle thousands of transactions per second. Finally, storage on the blockchain is really tricky, especially with the primitives exposed by Solidity. We have much better tools available, and especially ones that Web2 developers are familiar with. Ones that come to mind are relational databases and file systems. Depending on your needs, these can be purpose-built for very efficient storage and retrieval. So we should look into using these when possible. So I think that's a pretty clear list of benefits. And I just want to take one moment to highlight a particular project we engaged in that kicked off a lot of these conversations and really influenced how CIP-8 has evolved. In mid-2020, the Grameen Foundation launched a COVID-19 emergency relief project. The Grameen Foundation is an organization that creates tools and resources to help people help themselves. Their mission is to empower the poor, especially women, to create a world without poverty and hunger. With this pilot, thousands of women received $100 US to spend on essential goods and services. A portion of those, nearly 1,000, were selected to receive the funds through Valora via the Celo network. If you didn't follow this project at the time, the basic flow went a little something like this. Local microfinance institutions identified struggling entrepreneurs. These individuals registered on the Celo network via Valora. They received funds and then were able to spend these Celo dollars on essential goods and services. As you can imagine, this was a huge project with close collaboration between many partners across the world. Almost every layer of the blockchain ecosystem was touched here, including, but not limited to, custody, cash in, cash out, and payment processing. The part of the story that becomes especially relevant when talking CIP-8 origins is the Beam & Go payment processor story. At a high level, beneficiaries who had received the 100 Celo dollars would be able to spend that money in selected stores. Beam & Go would handle registering and tracking that payment, and later handle the selling of Celo dollar to reimburse the merchant. So we can imagine that Beam and Go needs to be tracking a few different things about these purchases, but top of mind are, for example, item IDs, this merchant ID, and potentially currency codes to verify the amounts converted from Celo dollars later on. So yeah, with any project, as with any project, there are a few issues. One of which, this transaction metadata problem, we felt like we could generalize into a solution that benefits the network as a whole. I previously mentioned this transfer with comment function, which is what we ended up using for this pilot. But it was never really meant for conveying structured data. Structured transaction metadata. And we ended up jumping through a lot of hoops to create these payloads as small as possible, to make these payloads as small as possible. And the second problem was this kind of age-old blockchain problem of transactions having to cost money. Users were confused when just the act of spending money actually cost them something. So, as we mentioned earlier, getting data off-chain is not a total fix for this problem, but it's a good start to reduce costs and confusion. So out of this came a proposal that we made to the community for a generalized solution. And this is a Celo improvement proposal. As a decentralized network, it's not always easy. It's not always as easy as writing code to fix problems then and there. There's a well-documented process to go through where we propose something to the ecosystem, get feedback on it, and then implement it. So yeah, exactly what is a CIP? A Celo improvement proposal. It's basically a design document outlining an improvement to the Celo network. It should provide context and background information, and most importantly, a detailed solution. Like everything that happens on Celo, these proposals are worked on in the open. So I encourage you to check them out, give feedback, and even try writing one yourself. Just wanted to take a moment to highlight a few previous proposals that have gone through. I'm not going to go into too much detail because there have been previous tech talks that did so. But just to give you an idea of what can be proposed, the first CIP on Celo was regarding validator run attestation services. These are what power our identity protocol, decentralized identity protocol. CIP-4 touched on the governance process with regard to hotfixes. This is especially relevant when we're dealing with exploits. We want to get those through quick. But I just want to highlight CIP-3. We can already see from the name, identity claims and metadata, that it's pretty related to CIP-8. So let's quickly cover what that was about. CIP-3 set the standard for basic off-chain data claims. The most common of which would be bidirectional identity claims. I can say, I own this domain, and then I can provide a DNS text record to attest that on the other side. I could also claim a Keybase account and provide a signature there. It also powered storing plain text data like URLs, and it powers the registering an attestation service URL if you're a validator. Yeah, but as I highlighted previously, like we needed a better way for more generalized storage, and CIP-3 wasn't quite cutting it. So that brings us to CIP-8. That's what we're all here for. CIP-8 is a standard for reading and writing off-chain data. It specifies the exact data paths Celo users should store data at and where to read it from. Specifies exactly how we could format data payloads in a way that the whole network can read them. And it also specifies a signature scheme to ensure that we're only reading authenticated data, or we're sure who the data came from. To provide a few concrete examples, because it might sound a little bit abstract, if I was to claim my name on chain, for example, we could upload a well-formed JSON object to our storage root, which in this case would be example.com. And the path to find it would be /account/name. It's important to note that these storage roots are always, these storage roots are some publicly accessible location on the internet that you can, like, reachable via HTTP. Yeah, I have another transaction metadata example here as well. Maybe if I was to transfer you some money, I would want to upload my transaction metadata at some path prefixed by the transaction hash, so the recipient knows where to find it. So right now, as of February 25th, CIP-8 has been finalized. A reference implementation has been written by C Labs. You can start using it in your dApps right now via Contract Kit. And it's going to be available very soon in Velora, powering our names and profile pictures integration, and transaction metadata coming soon after. Yeah, so how does CIP-8 work? That's going to be the rest of this talk, and we're going to do a bit of a deep dive into that. So I think it makes sense to zoom out for a minute and show, like, the end-to-end flow, and then we can get into the exact specifics of the protocol. So I made this little diagram to show the various players in the network. We have ourselves. We could be someone interested in storing data off-chain. We have the Celo network, as you know, made up of validators, full nodes, and light clients. These fellows over here could be recipients of transactions we're sending, or just anyone interested in reading wanting information from us. They could be friends. And yeah, the rest of this, and this is the rest of the internet. So for most of us, the rest of the internet is our major cloud provider of choice. This is where we're going to host our data. And as I mentioned, it's just important that it's at some publicly available endpoint and that it's highly available. It's unlikely we can get as high availability as the blockchain, but by going multi-cloud, we can get pretty close. So here's how it works. Basically, step one is to create a metadata file with our storage claim and store that somewhere publicly accessible. This publicly accessible location is going to become our storage root. So CIP-8 is implemented as an extension of CIP-3. I mentioned previously, like, a domain name claim or a key-based claim, and CIP-8 is just a storage claim. And so generating this metadata file, we have, like, helper functions in the Celo CLI, but basically it's just a well-formed JSON object with, like, an address and a signature in it. Step two is to save our metadata URL on-chain so others can look it up. Just acts as a pointer to the off-chain storage root. And step three is so we want to upload our name payload to the specified path that CIP-8 defines. So if Alice was to upload her name, she would have, like, this well-defined JSON object with a name property. She would upload that to /account/name with an accompanying signature. And yeah, that's it. That's all she needs to do from her end. Now, anyone on the network can look up her. Anyone who knows her address on chain can look up her storage root and read her name. So quickly, we'll go through that real quick. Yeah. So someone who's interested, maybe Bob, for example, would read the metadata URL associated with Alice's account. He reads that claim data. He gets back this well-formed JSON object, and he verifies the signature. And yeah, that's basically it for simple data claims, which is quite a nice experience for Celo users. We've now successfully gotten data off-chain, and it's well-formed. But that's everything so far is kind of assumed users are okay exposing this information to the world. And as we know, that's not typically the case. In reality, people like you and I, we often have a small set of peers we want to interact with regularly and privately. So the problem now becomes, how do we enable this off-chain communication in a privacy-preserving way? And we've taken a two-pronged approach. The first aspect of this approach is encrypting the off-chain data. This enforces the invariant that for a message between Alice and Bob, only these two would be able to read it. One issue here, though, is that we're still leaking quite a bit of metadata. If I encrypt a message to Bob, it could be my name, for example. The information that I've encrypted something to him is going to be public. Now, anyone who scrapes this database will know, at the very least, that I know Bob, and I may even have transacted with him. So we need a way to keep this metadata private. And this is the receiver privacy aspect of our CIP-8 implementation. Alice should be able to send information to Bob without someone figuring out it's destined for him. Yeah, so we're gonna like dive into how these work exactly, and a little bit confusing, but we're gonna cover the receiver privacy aspect first, and then come back to the encryption. But I promise it'll make sense afterwards. So to preserve receiver privacy, we need to look at our constraint, which is that all data stored via CIP-8 is in a public database. This means that we need to obfuscate the data path for a particular message in a way that prevents malicious actors looking at the database and gleaning that information. Finally, it should be easy for the interested parties to retrieve messages destined for them. Yeah, hope that's clear. If it's not, drop a comment in the chat. But yeah, let's just dive into exactly how that works. So we need to build this path which only Alice and Bob can compute, and it doesn't leak any metadata about the information being sent. Here's our algorithm that we've developed to build this path, and it might look a little foreign and a little scary, but I'm going to explain exactly how it works. Essentially, it's a two-step process where we compute a shared secret between Alice and Bob, and then we hash our message path with this shared secret. So the shared secret is the output of an elliptic curve Diffie-Hellman key agreement function. This is the part that's only computable by Alice and Bob. And for a source of randomness, we have settled on HMAC SHA-256. It's a well-known hash function, and most importantly, it's widely available on various platforms. So let's walk through like a concrete example of this because it's pretty hard to digest. So our data path, if we have this example of Alice sharing her name with Bob, we have this data path /account/name. As Alice, we have our own private key and our own public key, and we have Bob's public key. So step one is to compute this shared secret with this Diffie-Hellman handshake. Next, we need to build this unique path. It's comprised of our two public keys and this data path, account/name. It's important to note that when building this path, the order of precedence of public keys matters. When Alice sends a message to Bob, her public key should precede his. This means in the reverse scenario where Bob is sending a message to Alice, we don't have a clash of paths. Yeah, and our final step is to, as I said, like hash these two together. The shared secret acts as our salt. And And so now we have a path that's only computable by either Bob or Alice. And this process actually hides 2 bits of metadata, right? It hides who it's for, which is Bob, and it hides what the file contains. In this case, like the account name. But of course, like the act of reading this file would still reveal Alice's name. So let's quickly dive into the encryption piece of this puzzle. We've just specified a basic schema for encrypting data between parties. We settled on the widely available AES CTR encryption. And every message we send is encrypted with its own fresh symmetric key. When we store encrypted data as opposed to publicly available data, we suffix the data path with a .enc suffix. This is purely an implementation detail to make writing SDKs easier. Yeah, and so quickly coming back to this path I just mentioned in the previous section, we encrypt a message with this fresh symmetric key, and then we're encrypting that symmetric key to all of our recipients, and that's what lives at this unique path we've built, which is impossible for others to compute. Yeah, one more detail that's an implementation detail, but we also encrypt the key to ourselves. That means we always have a record of the data. So here's how it would look like very concretely in our database. If we were to provide our name encrypted to the Celo network, we basically upload our name and signature, the encrypted name and a signature of that encrypted name. And then we're distributing the keys to all of the recipients. So here there's 3 total recipients, and one of these is obviously ourselves. It's worth noting that with this approach, the data payload, which could be really large, here we're talking about names, but it could be images. These payloads are only stored once, and it's the lightweight encryption keys that are stored per user. This means in the update flow, if I was to upload, for example, a new profile picture, I don't have to re-encrypt my profile picture to 100 people if I have 100 friends. I just re-upload it once, and everyone else can read this new profile picture. This becomes particularly of note when we're talking about resource-constrained devices. So yeah, let's hop back to our example flow, and we'll see how our private communication works. So pretty similar, we upload our metadata claim. We save our URL on chain again. And then Alice thinks to herself, okay, I want to give Bob and only Bob access to my name. So she reads Bob's registered public key on chain. And then we do a few things. We basically follow the flow I just laid out. We generate a fresh symmetric key for this payload. We encrypt the payload. We upload it with the signature. We encrypt the message key with our own public key, so we always have a copy of it, and upload that. And then we do for the same for Bob's key. So we encrypt the key to Bob's public key and upload that with the accompanying signature. So now Bob has a way to retrieve Alice's name. For him to read Alice's name, he basically asks for her metadata URL and her registered public key on chain. Using the algorithm we outlined previously, he computes this unique ciphertext label and reads the entries from Alice's storage. And then finally, Bob can verify the signatures for each payload he receives, decrypt the key, decrypt the message key, and then finally decrypt the payload to read Alice's name. Yeah, so I guess I have a little demo to show you via the Celo CLI. It's pretty in the weeds, but maybe it will be interesting. So let me share something. Sorry, my computer's lagging a bit. Okay, so hope you can see that. So I have my Celo, my terminal up here, and I'm just going to like give a very in the weeds demonstration of like how this works. So I have a Google Cloud bucket pre-configured with my metadata URL. So I'm going to show an example of the reader and the writing flow. So I have my bucket with my metadata.json file. This is publicly available. I can have a look at it now, and it's just, you can see it's an address with a signature, a timestamp. It might be a little bit small actually, but so the first thing I want to do is I want to write my name to my, this is a bit big. Hopefully you can see that. But basically I'm calling the Celo CLI off-chain write function. And the inputs to that are obviously, oops, I should probably run. Sorry about that. So yeah, the inputs to this are my private key and my recipient's public key. So we'll just take a minute to send that. Cool. So that was the private flow, right? So we should expect like /account/name.enc, which we have. If we try to read this file, it's going to be it's just garbage. We can't see it. We can see we have the signature there, and yeah, we have the ciphertexts folder, which has 2 entries, one to ourselves and one to Bob, or our recipient. And so now I want to act as the recipient and read this data. And the input to this is the reader's private key and the writer's address. I understand that maybe it's a little bit hard to follow with all this text on screen. Yeah, but unfortunately Valora is not live yet, so I can't like show a really slick demo of this. So we can see that yeah, I was able to read this uploaded name. So yeah, and if I was to try and read this and I didn't provide the reader private key, we would expect this to fail, because without the reader's private key, there's no way to generate the shared secret, and no way to know where to find the key to decrypt the name. So then I quickly will just like write my name publicly. I've chosen not to encrypt it. There's like a little, oops. There's like a little prompt that says, "Would this operation will make your name public? Do you want to do this?" Click yes. And now if we go back to our bucket, we should see that we have like our name in plain text. And if we download that, we see that like, yeah, it's just this JSON object with name and Alex. And we have like an accompanying CLI command to read this data. I hope actually, I assume you've been seeing all this. Yeah, we have an accompanying command to like read this off-chain data. But we could actually just curl it as well, or use any HTTP client, but that would not check the signature. So that's what the Celo CLI command does here. Yeah. So I guess that was kind of the demo. And let me just bring up my notes again, sorry. Yeah, and I guess I hope that was a little bit underwhelming. Ideally, it's underwhelming. I mean, ideally, we've just made this thing work, and all the privacy implications are taken care of without developers or users having to worry about it. Yeah, so our pilot use case for CIP-8 that I've kind of been alluding to this whole talk is names and profile pictures. And this integration is going to land very soon in Valora. Any correctly configured picture or name on the Celo network will show up in Valora when a user transacts with them. But we have optimized the setup pretty heavily. As we saw earlier, there are many network hops needed to read and write data with CIP-8. So we've created a tailored experience optimized for Valora users on top of CIP-8 who are not self-sovereign. They don't have their own GitHub repository or their own Google Cloud bucket. They just have Valora, and it's up to us as C Labs who provide Valora to provide them with that storage bucket. So this optimization comes in the form of a service we run called Staccato. Staccato means storage in Esperanto. And this service, or something similar, is something any wallet could choose to run. However, it is an optimization, and it's not needed. With Staccato, Valora users provided a storage route based on their account address. Staccato handles reading and writing to the correct storage path based on the signature associated with some data. Yeah, this implementation is totally open source, like almost everything we do. So I'm not going to subject you to another walkthrough of this whole flow, but I think it was just important to note that there are quite a few network hops, which yeah, again becomes relevant in the context of low-end mobile devices. And with aggressive caching, here is how our most common flow, this is a user looking at a friend's photo, might look in Valora. They would already have their friend's public key. So when they're scrolling through the transaction feed, to display a photo, all we need to do is compute the unique storage path and read that picture from the Google Cloud bucket. This experience is on par with Web 2, right? It's just an HTTP request, which we're very happy about. And yeah, it's a great user experience for Valora users. For reading a new friend's picture, there's just one extra step where they need to read that user's public key. Now that they have the public key, they're able to read from storage as per usual. And for a non-Valora user, the flow is as normal. We read the metadata URL and the public key, and then we're able to read the data from their storage route. So yeah, our implementation in Valora, it prefers other Valora users, but it gracefully falls back to the standard decentralized storage mechanism. And so that's kind of it. That's CIP-8 in a nutshell. It's generalized off-chain data storage. We support it supports public and privately shared data. Yeah, moving data off-chain can reap many benefits for the network, including but not limited to increased transaction throughput, lower interaction costs, and of course, richer end user experiences, which is pretty important for the Celo network. So if we take a quick moment to look ahead, the future of CIP-8 looks a little bit like this. Our number one priority is to make these APIs more accessible to developers building on Celo. That means building out more standards for what we store off-chain. We have names and profile pictures where we're already on top of developing transaction or transfer metadata. But there's a whole story around identity and contract verification and verification in general that we're only just beginning to scratch the surface of. We also want to look into a possible integration with Wallet Connect. This would allow dApps in a permissioned way to access users' off-chain data via a wallet interface. This is super powerful, and this is still very early days. We're only just thinking about this. So if you have use cases in mind, or this excites you, be sure to jump into our Discord and chat with us. We're there every day, so we'd love to hear what you have to say. And finally, just want to mention that maybe watching this talk gave you some ideas for your own Celo improvement proposal. Maybe you just want to get more involved in the community. And whatever it may be, we definitely encourage you to make your voice heard and take part in our proposal process. We're approaching nearly 40 proposals that have been written and accepted, and they touch all areas of the stack. So there's definitely something for everyone. And that's it. I see. Yeah, that was my CIP-8 Tech Talk. I hope you enjoyed it.
Awesome. Thank you, Alex. So next Tuesday, we have a Celo intro talk again by our CTO, Marek, and as well as Gerald. So I'm looking forward to that. So please join next Tuesday. And let's get to the Q&A session. We have 3 questions. One of the questions I actually posted for the audience. Please let me know and then post it here if there are other Celo components and building blocks that technology stack that you want to learn more and want to be covered by Celo Tech Talk. And so the first question, can you revoke access to existing data?
It's a great question. And it kind of, yeah, I mean, what does revoking access mean? I would challenge with. If I've uploaded my name and someone reads it, they have it forever. And I can't do anything on my end to take that away from them. So that means, the revoking process basically can only stop future people from reading it. And that looks like, and for public data, I could just delete the file. And for private data, when I decide to upload a new picture, I could decide to rotate the key used to encrypt everything. Yeah, I think that's basically the gist of it.
Okay, next, did that answer your question? Great, Cody. Okay.
Yeah.
And the next question is, why not Filecoin instead of cloud storage like AWS? Good question.
Yeah, I think the chat we had internally was kind of more around, should we use IPFS or should we use just standard HTTP? I'm not sure if we actually discussed Filecoin. I'll be honest, I don't know so much about it. But I think the key here, in my eyes, is like, this is a really low-hanging fruit we can tackle right now to get data off-chain. And HTTP is a protocol that everyone speaks. It's really well supported, and and even IPFS, right? That adds a whole new layer of complexity by having to host a node. So I personally would love to talk more about this. So yeah, Bernardo just said Filecoin's a layer on top of IPFS. Yeah, I think then I guess requires running a node, which I think is a little bit more overhead than we wanted right now. But yeah, the future is definitely decentralization. So we are looking at these alternatives. Happy to chat more on Discord, as I said, if you have cool ideas there.
I think similar to like the way we chose the blockchain versus other technology is now we are not focusing on the technology per se, but more on the mission of like what the solution look like and how that benefits more end users. So if we choose like a Filecoin and have integration, would that also slow down the performance of the solution as well?
I don't want to comment on IPFS so much. I don't know that much about it, but I believe like my assumption is that like data is replicated across the network, and if your local node doesn't have it, it's going to have to go find it.
Okay, I actually skipped the one question by now. What kind of applications do you envision on CIP-8?
Yeah, I kind of touched on this, but the world is really our oyster here. I think like getting the network to a point where all this superfluous metadata like names, descriptions, transfer metadata, we're going to be in a really good spot. But after that, we've been having some really cool talks internally about contract verification, audit badges. You can imagine if you were trying to interact with a dApp on your phone and it's asking you to sign a transaction for a smart contract, we could provide a badge saying, yeah, this smart contract has been audited by OpenZeppelin. We can say like, here's a green badge, saying that like this is legit. I think there's also another. I kind of also touched on this with the Wallet Connect integration, but being able to permission dApps to write to your off-chain storage is crazy powerful. And as long as we present that in a way that's really accessible for our end users, that's going to be super cool. That means dApps they don't need to run a database of their own, right? They can just access the users on-chain storage, and it's like fully decentralized. Yeah.
Last question. As a developer building on Celo, will I be able to fetch username when connecting with the Valora?
I guess you're kind of asking, like, can you access their storage root via... I think what you mean to ask is if you're a dApp, can you get the user's name from their wallet? And I would argue, yes, that is like definitely going to be part of the integration we're thinking about. Yeah, I kind of skipped ahead, and we're already talking about writing to a user's off-chain storage, but reading from their off-chain storage is definitely feasible as well. Yeah, that integration would look a little bit like the wallet interface. The connection between the dApp and the wallet provides an interface for like get name, and the wallet handles all the decryption aspect of it. If it's decrypted, if it's encrypted, the name that is, and then sends it to the dApp. Obviously, if the metadata is public, the dApp itself can just read it. So yeah.
All right. Bernardo actually accepted the invite to come on the screen. So did Alex's response answer your question?
Yeah. The question was just since Alex was mentioning the having the names and the pictures available through those private and public registries. So I was wondering if I could get the names for the app, the same way that we are getting like the phone number and the address.
Yeah, for sure. Yeah. I assume that right now you're probably going through DAppKit, right, to get that information? Yeah. So we're looking at basically a more powerful integration. You may have heard of Wallet Connect. And this will allow for, a better handshake between the DApp and the wallet to assess like what they can transfer back and forth. And yeah, like I said, I kind of skipped forward to like actually allowing writes, but allowing reads is definitely the first good step.
Okay, thank you.
No worries.
Awesome. Thank you, Bernardo.
Cool.
So I don't think there's any more questions.
I think we're good. It's a good 15-minute presentation.
Like last week, York actually mentioned about how Captain is hiring. So we are still hiring. Now we'll be pleased to hear that I'm actually mentioning about it. We are hiring, C-Labs hiring across the board and across the teams. Thank you, Cody. So you can follow the link that Cody just selected on the chat messaging board. Sweet. If this sounds like exciting project to you, please join us. Right. Thank you, Alex, for your talk today, and thank you, audience, for joining us today.
Thank you all.
Bye.
See ya.